something I really shouldn't do, and I'm going to plot the sepal length. I'm going to plot a qualitative data, right? And it's going to give me the scatter plot. But what I want us to notice is that in the data set iris, it's sorted by type. So the first 50 are the setosa type of iris. The next 50 are versicolor, and the last 50 are virginica. And notice we have this what looks like a positive slope to this line. We aren't going to say correlation because there's no correlation. This is just an index of flowers. But that leads me to think that there are differences in the distribution of sepal length for each of our subspecies. So what I want to do is I want to make a box plot. Now, if I make a box plot just of my iris sepal length data, I can give it a title, right? We say main is sepal length. We could say my Y label is also sepal length. You'll see why that's going to be in just a second. Actually, let me do that for us first. Right, so here we have a distribution of our sepal length. So this is our mean. Here is our minimum. Here's our maximum. Right, so I could use my Y label to label that sepal length. Maybe this should be box plot of sepal length, right? So I've got this wide distribution, but we know from looking at the plot, even when we weren't supposed to, that it differs for each of the subspecies. So I want to break them up. And I'm going to do that by saying I want a box plot of our sepal length by the species. And I'm actually going to not call iris. I'm just going to do sepal length tilde species, not species table, and not explanation point. That should be a tilde. And then I'm going to let my data set equal iris. And let's go ahead and do this and see what happens. So look, now we have it broken up. Note, this little dot means that there's an outlier, but we can really see that there is a difference between the sepal lengths of each of the different types of flowers.